In part 2 of our tutorial series, we're going to be talking about double-check locking. So this is used to reduce overhead of acquiring a lock by testing that lock with a non-thread safe mechanism before attempting to acquire the lock using a synchronized thread safe mechanism. This is typically used when implementing lazy initialization in a multi-thread environment, which is common with the singleton pattern. A lot of times you'll see singleton and double check locking together. Alright, so here we've got some diagrams, and then we'll look at some code examples. So the diagram on the right, we've got a flow chart showing the flow of control with our double check locking. So first part here, request the object reference, do the non-thread safe test to see if it exists. If it does, return the reference. If not, maybe it doesn't. So we enter our thread safe check. Here we see if it exists. If it does, return it. If not, then it gets instantiated. Then that reference is returned. Okay, on the diagram on the left here, we've got a UML mockup showing our first test example here. The once class here implements the when method, which has our double check locking in there. The thread race test is just our test class. So let's take a look at the code here in Eclipse, and I'll explain it some more. Alright, so our once class here has the this completed variable here. So this is our control variable. This is what we're checking. In the when method, we've got just our double check locking implemented here. Here first is our non-thread safe check. Then if we need to go deeper, we go through our synchronized thread safe method. And if we get to here, the winning thread ID is printed out, and completed is set to true, and so no other threads should be able to reach this point. Okay, let's look at our test class here. So in our main, create our once object, and then we go into this loop where we just create a number of threads using this create test thread helper class. Okay, so in this class here, just are creating threads with random startup delays with values between 0 and 1 second, and then they call once.win. So each time we run this, we should see a different thread ID winning, essentially. So let's go ahead and run that and see. Okay, this time the winning thread is 32. Let's run it again. 35. Now 21. 15. 18. Everything looks good. We only see one print out here, so that means everything is being synchronized, which is good. Okay, let's talk about example applications. Now let's go ahead and let's build on to the car application we're going with, the car example, and let's add cruise control to our car. So we're going to need to add a cruise control object. We're going to need to add set speed, accel, and decel methods for the steering wheel control thread to use. We'll need to be able to cancel cruise control from either the accelerator or brake foot control thread, this is implementing the methods we already had in our car object from part 1. And we need to ensure that only one cruise controller exists, so the singleton pattern would be a good choice here. Okay, let's check out this diagram here. So we've got our original our car class here. We've added a cruise method here for setting cruise control. We've got our new cruise control class here too, which we see we've got our instance here and our get instance. So this is telltale sign of a singleton pattern. We've got our set speed method, get speed, accel, decel, and cancel. And we also have our test class here that is going to run all this for us. Okay, let's jump over to Eclipse here and look at the code. Alright, so yeah, as mentioned before, we're using the singleton pattern. So we've got our instance of our object here, our private constructor, our get instance method, where we've got double check locking implemented here around our object instantiation. We've got our set speed control or set speed method, get speed, accel, decel, and cancel. Okay, looking over at our car class, we've added a cruising state. To the accelerate method, we added a cruise control cancel. and to the brake method at a similar cruise control cancel. We also check the speed to see if cruise control was on. We go ahead and set the car speed to whatever the cruise control speed was, and we do that by checking to see whether it's 0 or not. Basically, if it's 0, cruise control is probably off, or had not been initialized yet. All right, we added a cruise method as well, which kept the balking pattern going and added this check here. If the car is not running and you try to set cruise control, it spits out an error message. Otherwise, we go ahead and set the cruise control to the current speed of the car. All right, in our test class here, we've got 2 threads. This time we've got one to simulate foot controls and one to simulate steering wheel controls. So the foot control uses our car methods that we saw in the previous examples. To start, accelerate some more, wait, brake, wait again, and brake again. In our steering wheel control thread, we start up, immediately wait a little bit, so we're waiting for the car to start and accelerate some, then we set cruise control to the current car speed. Have a small loop where we increment the speed using the cruise control .excel method some. And then by the time that finishes, slightly after that, we should hit this part in the foot control thread, which should cancel cruise control and stop the car. Or slow the car down, sorry, not stop it. Okay, let's run this and we'll take a look here, the output, see what's going on. Okay, so we've got ignition success, accelerate, which cancels cruise control. It's not running, so that's fine. Accelerate, braking. Here we go, we've enabled cruise control at this point, cruising at 10 miles an hour. And slowly we increase that up to 15, and the thread number 1, the foot control thread, brakes again, which cancels cruise control, and the car slows to 5. Okay, well, let's talk about some implications, some pros and cons of this pattern. So pros, it reduces overhead, increases efficiency and performance. Some cons, this can be unsafe with some language and hardware combinations. If you have multi-core processors and some certain programming languages, and you try to use double-checked locking, you can get into some conditions, some false conditions there. Double-checked locking is also sometimes considered an anti-pattern for various reasons. All right, so that's the end of part 2. So our next presentation, part 3, is going to be on guarded suspension. So be sure to check that out.